Hi, this is our 390 Brother Grimmett project for electricity and magnetism. My name is Heidi Blunt.
I am Erick Stone.
And I'm Barrett.
And this is our project. So we have two boards. I'll let you zoom. So two boards that are together and they have magnets inside the boards, and the boards, and they're in like a circular pattern on the board, and then we have this our little circuit here. It has three different circuits, and we'll talk about the design of the circuit in a minute, but they have a switch that can turn it on and off, and Hall effect sensors, and so as we can spin it around, it will, as the magnets come in close contact with the magnets, as the Hall effect sensors come in close contact with the magnets, then they will light up the LEDs as shown. Can you see?
Yeah.
You can change the color and such.
So there's a red, yellow, and green LED that
Yes.
light up.
Okay?
So Hall effect sensors themselves, they're awesome. When they come into contact with an electromagnetic field, they trigger an on switch. You can see from that our circuit design laid out here. We've got two batteries, 3 volt in series, and we've got the Hall effect sensor here. Our switch is here. When the Hall effect sensor comes in range of a magnet or electromagnetic field, whether artificial or natural, this switch inside of it turns on, enabling this circuit to go through here and down to ground. Our LED turns on. We've got a resistor there to handle sudden changes in amperage, and a coil, which we'll talk about in a second. So, the coil is our next step, if you will. And Jared will talk about that.
So, looking at our project again, we right now we have to kind of push it around and see, just push it to make it work. But the next step would be to make it so it goes around on its own, that it's self-propelled, and the way to do that is through that coil. The current going through a wire, or a loop of wire, can create a magnetic field which acts just like a magnet, and by turning that on and off, as this thing passes by the magnets inside the board, we can have that coil inside this circuit here that would repel and attract to, in essence, propel this thing around on its own. And that's the next step, and we wanted to do this because we thought it would be an awesome demo for like a physics teacher that would want to teach about electricity and magnetism and how the two can interact with each other.
So, Hall effect sensors again. They are widely used in industry. A car, for example, you have a motor which spins, and you have a Hall effect sensor here, which goes to the car's computer, and a battery, we'll say here, not a battery, a magnet, we'll say here, on the motor. As the motor spins, it goes in contact with this, triggering on, sending a signal to the car's computer. Goes again, goes again, goes again, keeping track of how fast the motor's spinning. Also, fluid levels. You have some kind of container, and you've got fluid in it, and you've got a little Hall effect sensor here, and a floating magnet. When the fluid level goes down and reaches this level that it turns on the switch, send out an alert, maybe refill the container with fluid, notify someone that, hey, it's reached a critical level, something needs to happen at this time. So, practical application, this is widely used everywhere. Any industry, any manufacturing industry, there's a lot of potential for Hall effect sensors and a lot of already in existence usage. So, in essence, what we want to get across to others is that, hey, this is here. Learn how to work with it, because it will help you in your different fields.